Let's review how to name ionic compounds. Pause and review as much as necessary. Remember that in ionic bonding, I'm joining together metals and nonmetals. When I am joining together the groups of 1 and 2 metals, with nonmetals, anything on this side, then the rules are really simple. I just keep the cation, the metal's name, and I change the ending of the nonmetal name to, say, IDE. So for example, if I join together sodium, which is a metal, with chlorine, which is a nonmetal, I get sodium chloride. I just changed the ending to IDE. And that applies for anything that is 1 and 2 metal with anything that is a nonmetal. Now, when I'm joining together any other metals other than the ones in group 1 and 2, so all of these, then I still keep the name of the cation, so I still keep the name of the metal, and I still change the ending of the anion to say IDE, like chloride. But I need to figure out how many Roman numerals to give, depending on how many electrons each cation atom gives to make the compound a neutral charge. So for example, if I have 3 of the copper atoms bonded with 1 atom of phosphorus, first I need to identify how many electrons does the nonmetal need. So in this case, it's phosphorus. I look at phosphorus and I find it in the periodic table. I see that it's in group 1 to skip over 3 to 12, 13, 14, 15. I see that it's in group 15. So in order for me to have 8 valence electrons, I need 3 more. So I need 3 electrons more for this group. So I've identified how many it needs. This phosphorus needs 3 electrons. I see that copper, there's 3 of them. So each copper only needs to give away 1 to the phosphorus. So for example, I have 3 coppers, 1, 2, 3. I have 1 phosphorus. This phosphorus needs 1, 2, 3 more electrons. So this copper gives away 1, this copper gives away 1, and this copper gives away 1. And that's what's going to happen to this compound every single time. So for copper 3 phosphorus, I named this compound as copper 1 because each one of copper only gives away 1 electron. Copper 1 phosphide IDE because I changed the ending to say IDE. Alright, so let's do some other examples involving Roman numerals from your homework. One of the examples that we have is this. So first, I identify where bromine is, and I see that it is right here. So I determine how many electrons does it need. Again, I determined that by looking at the group numbers. So this is group 1, this is group 2. Remember to skip over transition metals because they have different oxidation number depending on who they bond with. So don't count those. This one is a 3, this one's a 4, 5, 6, 7, 8. The last group has 8 valence electrons. According to our octet rule, they're full. They don't want to bond with anyone else. Now, bromine has 7, which means they need 1 more, right? So they need 1 more. 1 electron more. That means they're more likely to take away an electron, so their oxidation state then is just -1. I also see that there's 3 bromine atoms. So if each one is a -1 charge, and there's 3 of them, then obviously the overall charge right now is -3. In order for me to make an overall charge neutral to 0, then how many does each titanium atom need to give away? And the answer is 3. So I use that number to name it. So I'm going to name this titanium. I'm not going to write it out fully, but write it out fully. 3, 1, 2, 3, bromide, IDE, to change the ending. Okay, let's do the second example. The first step is for me to find selenium, which is my anion in the periodic table. So I find it, which is right here. I know that by counting the group numbers, this group has 6 valence electrons, so which tells me I need 2 more. Each one selenium needs 2 more. So right now its charge is -2. It's going to end up taking away 2 electrons. So -2, but there are 2 of them right here, 2. So right now the overall charge is -4. So something plus -4 is going to give me 0. I see that plus 4 plus -4 is going to give me 0. And I only divide it by 1 because there's only one tin, which tells me that its name then is going to be tin 4 because it's giving away 4 electrons. Tin 4 selenide. Oh, D-E, selenide, IDE. Okay, but what about all those special metals that I told you about that do not belong in group 1 or 2, that are either the transition metals or the other metals that always have 1 oxidation number, which means they are always going to give away the same number of electrons. Remember I told you to memorize these? So silver always gives away 1, zinc will always give away 2, aluminum always 3, and scandium always 3. So these will not require, do not require Roman numerals. So remember that. So for example, in this one, zinc, 3 of them bonded with 1 phosphorus. I don't even need to look at anything else. I treat it like it's a group 1,2 metal. So I just name it the way it is, zinc phosphide. So that's really easy. All right, so let's talk about the polyatomic ions that we learned in class. We mostly focused on oxyanions, which means they contain oxygen, oxy, right? So if you see something that has like more than 2 types of elements, as in you have 3 different types of elements, and it ends with, an O, then you know that it is going to be an oxyanion. In its most common form, I am going to end it with ATE. And what you see down here are the oxyanions in its most common state. So all of these are going to end with ATE. If I have 1 more oxygen than the common form, I'm going to add per as a prefix. So for example, I'm going to say perchromate. If I have CrO5, then I'm going to name it perchromate. If I have 1 less than the common form, I change the ending to say ITE. So for example, if this one had PO3, I would name it phosphite, not phosphate. If I have 1 less than the ite form, then I add the hypo as a prefix. So if I had, let's erase that one, if I had PO2, then I would call it hypophosphite. So how do I name the ones that are oxyanions plus metals? You keep the same rule for metals. If you're bonding with group 1 or 2 metal, you just keep the metal's name. If I'm bonding with any other metals, transition metals, I am going to add the Roman numeral according to how many electrons do I need to give. And you're also going to just follow the rules for oxyanions that we saw on the previous page for prefix and the ending. Remember that if it's in the most common form, then you just end it with ATE. So for example, this is also from your homework. If I have lithium, 2 of them bonded with 1 sulfur, 3 oxygens, I treat them as if this sulfur and oxygen is one thing. So remember from our previous page that the most common form for this is actually SO4, and that would give it the name sulfate. So I automatically know it's 1 less oxygen, so it's going to be called sulfite. I already know that. And I also know that lithium is a group 1 metal, so I don't have to worry about giving it a Roman numeral. I just name it just the same. So I say lithium sulfite. Let's do the second example. Vanadium is a transition metal, so I already know that I'm going to have to give it some kind of Roman numeral. I also see that SO4 is a sulfate, right, from our previous page. And recall that sulfate has -2 charge, okay? So I see that there's 3 of them. That's why I have to put this guy in parentheses to say that there are 3 of these ions right here. So I say -2 times 3 of them will give me -6. But I see that there are 2 vanadiums, so in order for me to make this even, I would say +6 plus -6 equals 0, but there are 2 vanadium atoms, so then each one's gonna be +3 charge. So I can say vanadium 3, 1, 2, 3, sulfate. Finish your homework as more exercise and check your answers against the answer sheet. And the ones that you get wrong, watch this video again and see where you're making the mistakes. And ask me specific questions so I can help you. Alright, lastly, remember I told you guys to memorize these, so make sure you do that. Ammonium is NH4+, which means that it's a cation, which means it's always going to come first. So it's going to give away 1 electron, you're always going to name it first. All the other ones, the funky ones, hydroxide, cyanide, and acetate, they are anions, but they're all -1 anions, so that's easy to remember. Also, bicarbonate comes from the carbonate family. We learned that CO3 is a carbonate which has -2 charge, but since I added a hydrogen to this carbonate, this one's charge becomes -1 also. So this one is a -1 also. Study the charts. Study the ones I told you to memorize. Be ready for a pop quiz anytime throughout the week. See you in class.